Well, hi everyone. I think I have a really interesting video for you today. It's a quite fascinating situation that I came across recently as a result of a news story about NASA conducting flights for their specialty Gulfstream 3 aircraft that they outfit with side aperture radar as well as ground penetrating radar in this case. So I'll go over what their findings were, that they were actually inadvertent, but then what it means for the installation that was installed there in Greenland in 1959, 1960, what that was all about, and just get into a lot of the technical aspects for the construction of this base for military operations back in the late 50s, early 60s. So we have this article from NASA Earth Observatory, and by the way, all the links for these various references are in the description to this video in case you want to check it out yourself. And you can see here that they discovered or rediscovered Camp Century. They weren't looking for it. They were taking measurements of the extensive ice cap in Greenland, and at this location of the Greenland ice cap, the thickness of the ice is around 6,000 feet over the natural ground at that location, and they had uncovered the presence of the Camp Century base. And this was a military installation that was built to conduct research in what it was like to live and work in Arctic conditions. And there were also specific military goals in mind. And again, I'm going to get into the details of that. Now, these images must be from the ground penetrating radar because side aperture radar cannot penetrate ice. And that article is a little confusing, but there's no way side aperture radar is going to penetrate 130 feet or so past the surface of ice. But it's quite interesting. They're using it for various geological and climatological studies around the Earth. This is a GPR profile showing buried material at a depth of around 100 feet below the surface of the ice. Now, this is the base complex, and it was constructed using cut and cover methods. So if you're not already familiar with cut and cover, it's a common construction technique in civil engineering where you make an excavation, you build what you need to build, and then you backfill it. In this case, they were working with snow and ice. And it was an extensive camp under the ice. They had living quarters, kitchen and mess hall, bathrooms, showers, recreation, library, pretty much everything that you would ever want for a military base. And this base was made to accommodate up to 200 people at any given time. It looks like the original construction was at a depth of around 70 feet below the surface of the ice. And they used increasingly wider cuts at the base of the excavation, which was by design. And then they brought in these prefabricated housing units and other infrastructure. So to give you an idea, this is the location of Camp Century. They called it Camp Century because it was about 100 miles from the nearest camp just to the east of Thule, Greenland. The first European to go to Greenland was Eric the Red, and it was part of his exile from Iceland that he was trying to entice other people to join him in Greenland. And so given how much harsher the Greenland climate is compared to Iceland, I think this is one of the earliest examples of a real estate scam, because he knew if he gave the land a new name that was enticing, that more people would be likely to move from Iceland to Greenland. This was over 1,000 years ago. So let's just look at this Google Earth image. We'll zoom in. We're not going to see a whole lot but white as we zoom in here. So that's a long way to travel under very extreme weather conditions for most of the year. So as I mentioned, you have the Thule Air Force Base, which is now a Space Force installation. And then the distance to Camp Century was about 138 miles from this Camp Tuto, just outside of Thule. Now, I got a lot of information for this video from a U.S. Army film, as well as a U.S. Army technical publication. Again, links are in the description, but you just gotta love these old style videos. It reminds me of watching film strips and other films in the 1970s in elementary school. I'll just run a brief segment of this video so you get a flavor for how it was presented.
On the top of the world, below the surface of a giant ice cap, a city is buried. Today on the island of Greenland, As part of man's continuing efforts to master the secrets of survival in the Arctic, the United States Army has established an unprecedented nuclear-powered Arctic Research Center.
So you gotta love that music. It almost sounded like an old 60s science fiction movie. The remoteness of this location is no joke. I had to haul everything in, the people, the equipment, all the materials. So they use these tracked vehicles. These are their personnel carriers. It's kind of interesting that the Army painted all their equipment, including aircraft, orange, which makes sense. It's high contrast against the snow and ice. So they're showing the layout of this camp. Their criteria was to find a part of the ice cap that was sloped at less than 1 degree. So they're just laying out the boundaries of this camp. And I'll show you what they use to excavate the snow and ice to create these tunnels that they install all these facilities. This is that technical manual that I mentioned earlier. And so I have pulled a lot of figures out of this manual, and it's about a 70-page long document. And I read it in its entirety just to get background information for this video, and it's extremely interesting. So this photo shows a typical Arctic or polar installation where it's above ground and you use jacks to be able to raise the building above the snow and ice that accumulates each year. And for this part of Greenland, they determined that it was going to be too big of an effort to maintain a facility above ground. So they actually did wind tunnel studies to determine the amount of snow accumulation that would occur around these structures. And I think they figured on average about 4 feet of new snow would accumulate each year, which would later turn to ice. So they decided the only way to go with an installation at this location was to go below ground or below the ice. So this is another segment from this video. It just shows you that this ice sheet is moving. You see all these tension cracks, these crevasses that have opened up across the ice sheet. So it's quite a dynamic environment. Now, Alfred Wegener was a German scientist who did a lot of geological and climatological studies. He spent a lot of time in Greenland, mostly for meteorological station installation, and he actually died in Greenland. I was always told he fell in a crevasse, but later I learned it was from exposure. But he's the father of plate tectonic theory, well over 100 years ago. And he noticed, as many people have, if they look at a globe, that the continent's outlines would fit together if pushed together. And he fleshed out the theory of plate tectonics, which is still in effect today. So what was interesting about this technical report about how they built this installation in the snow and ice is that they did a lot of engineering studies that essentially treated the snow and ice as a soil or a rock material. So they looked at the density versus depth profiles for the ice sheet. They looked at temperature as a function of depth below the ice cap. The warmer temperatures, if you want to call it that, which is about minus 11 degrees Fahrenheit at the surface, and it goes to around minus 12, around 300 feet, and then the temperature slowly increases again with depth. So let's just run some more of these video segments showing the tremendous effort to bring in materials and equipment for the construction of this below ice military installation. They brought in all their facilities as prefabricated units, and they actually had practice putting these units together before they transported it to Greenland to make sure they understood that everything would fit up, that they had all the parts. It was a very meticulous operation. So quite an extensive network of rooms and trenches. You have the central communication trench. You have the nuclear reactor that's in the top right of the screen. So how did they construct these tunnels? Well, they used this machine that they got from Switzerland. It was a specially made piece of equipment to clear the roads in the high Swiss Alps. And these machines were called Peter machines, and they used them as a mill to carefully control small thicknesses of snow and ice removal in any given pass. So they called these Peter mills. You see it really throws out the pulverized snow and ice. So one of the key aspects of this was to try and use as much in situ material, snow and ice, to limit the amount of materials that needed to be used for the construction of this facility. So they're cutting the trenches, they're widening the cuts with depth. And what they do is they throw the snow and ice to the outside of the trench, and then when they installed these corrugated metal forms, they would use the mill again to throw snow and ice over the top in lifts and essentially let it melt a little bit in the direct sunlight and refreeze. And they found that was the most dense and strongest configuration for the snow and ice cap over these tunnels. So the idea is they use these forms until the snow and ice cover had hardened enough, and then they would reuse these forms in other parts of the construction to save money. And they use saws to cut the snow and ice into blocks, much as somebody might do to construct an igloo. So they use these blocks to form walls at the end of the tunnel. And it just shows them backfilling over the tops of the tunnels. Looks to me like the depth to the bottom of these tunnels is around 40 or 50 feet. And then in the ensuing 60 plus years, the depth is now around 130 feet below the surface of the ice cap. And so then they had to install all their equipment, all their flooring over stringers to create airspace such that the heated building structures wouldn't melt the underlying or adjacent snow and ice. So they're just leveling everything out here. Wonder where they got that wood. Certainly they didn't get it from Greenland. I mean, it's really impressive thinking about what these people accomplished in very harsh working conditions and environment. Very, very skilled people. This was all headed up by the U.S. Army Corps of Engineers for the construction of this facility. And so they're getting ready to install these prefabricated building components after they get the flooring installed. But again, they practiced this installation before they brought everything to Greenland to make sure they knew how to do it efficiently and they had all the parts and weren't missing anything. It's not like you could go to the local hardware store if you were. So just another view of one of these tunnels. They would have these open-ended tunnels so that they could bring equipment in and out. So they had a complete plant facility, so power generation, water, sewage disposal. And how they got their water was they used steam elements to melt the ice to a depth where the ice was dense enough that it was actually impermeable to water, so that essentially they're creating a water well by melting the ice. Here's a film segment showing that. They've got a riser, they've got a hose with these steam jets, and then they have a submersible pump to pump the melted glacial ice, which was very pure. The technical report said it was as pure as triple distilled water, which I'm curious if they added minerals back to it, because drinking highly distilled water is not good for you from a hydration standpoint. Plus, most people don't like the taste of highly distilled water. I think it's a natural biological response to not drink something that's not good for you. Okay, it shows them hauling in the components for the nuclear plant, this modular nuclear plant. And by the way, there was no secret about them constructing this base or the fact that they were going to have a nuclear reactor powering the base. But there were some highly classified aspects of what they were doing here that I'll get into here in a moment. This plant was made by Alco Products out of Schenectady, New York. That company's no longer in business. Now let's look at some of the stats for this reactor. And if you look at miscellaneous statistics showing the monthly dosage from the radioactive aspects of this reactor, 50 millirem per month of gamma and 40 millirem a month for neutron particles, which is quite high from what I understand. In fact, after they installed this reactor and got it up and running, they didn't originally have any shielding for this reactor, and they found that the radioactive dose rate was far too high to be safe for the personnel in this facility. So they came back and later installed some shielding to better protect the workers or the soldiers that were there. So the reactor was about a third of the cost of this entire installation at $2.5 million. So to take a dollar in 1959 and equate it to the value of a dollar today, you'd have to multiply it by 10. So reactor, this modular reactor, $25 million in today's dollars. So let's just run another segment of this film showing them getting the reactor up and running. Shows them handling the new uranium-235 fuel rods. Somehow I have a feeling that industrial hygiene standards have changed since this time. Notice that nobody here is wearing a respirator. I'm pretty sure they should be wearing a respirator. But they were concerned about tracking radioactive dust back to their workspace, so they're wearing little booties. But no indication that they showered or wore respirators. Shows them fueling the reactor here. They're installing a series of fuel rods and then control rods. And of course, this is back in the slide rule days where they're calculating the yield of the reactor as they power it up. Very interesting. Looks like a lot of officers there running the nuclear reactor. And they try to portray this installation as having all the comforts of home, which it is really impressive given how remote it is, but I imagine there was a lot of psychological stress being so far underground and not having any natural light for hours at a time. Now, they did have some technical difficulties with this tunnel system. In some cases, they didn't allow enough time for the overlying snow and ice to thaw and refreeze into a stable structure. So then additional stress was transferred to these metal elements that deformed, and in some cases they realized they couldn't remove the metal forms. I mean, that was the idea, is just to leave a cap of snow and ice in place that was stable, and they could reuse these metal galvanized sections in other parts of the base construction. And part of the problem is there was more warming in the facility than they had originally planned. So this is a plot of two curves. One is the ambient outside temperature, and then the other is the temperature inside the tunnels. So ice behaves as a viscoelastic solid. That means under constant stress, it's going to change shape over time. So if you create an opening in a viscoelastic material that's subject to constant stress, those openings will try to close over time. And this is what they found, that these tunnels, the heights changed are about a foot a year in some places and as much as over 3 feet a year in others. And this wasn't a surprise, but the rate of the deformation was faster than they had anticipated. So they drilled a hole from the surface down to a depth of over 1,100 feet. The hole started out being 5.85 inches in diameter. So after about a year at a depth of 1,100 feet, the hole is less than half of its original diameter. So let's look at the cost. Shows you the cost in 1959 dollars, the various components. So a total of about $8 million. So 80 million in today's dollars, which you couldn't construct a shed for $80 million in Greenland today, I don't think. And they did a lot of interesting research. This shows their drill rig for collecting ice cores through the ice cap. And by analyzing the trapped atmospheric gases in these ice cores and through other analysis, they discovered that at this location of the ice cap, which is currently 6,000 feet thick, 400,000 years ago, there was no ice. So considerably warmer than today at this location. So ultimately, they found it was too difficult to maintain these tunnel spaces. They had to periodically come in and re-enlarge the openings, and it was just prohibitively expensive in terms of time and money to maintain this facility. Although it did run for about 8 years, so it was really impressive as a proof of concept. But you know, they weren't spending all this time and money just to see if they can have people living under the ice. It wasn't until the 90s that the whole program was declassified. And what they were really up to was part of this project Iceworm, where the plan was to install mobile nuclear launchers inside these tunnels below the ice. And that program was scrapped. In fact, they removed the on-site modular reactor in 1967. So that facility's been abandoned since the late 60s. But I can understand why it would have been attractive to the US government to have mobile launch capabilities for nuclear missiles in Greenland, given the proximity to the Soviet Union. And this was the most intense period of the Cold War. And I'm sure having ICBMs deployed in Greenland would have been far preferred to what they were doing with the B-52s, where they would have as many as 7 or 12 B-52 bombers equipped with nuclear bombs in the air at any given time, 24/7, which hugely difficult and expensive endeavor. And that program ran from the early 60s to 1968. And in 1968, there was a crash of a nuclear-equipped B-52. It spread contamination just all over the ice cap in this location near Thule. So when they abandoned this base in the late 60s, the idea was, you know, it'll never see the light of day again. This will just be increasingly buried in accumulating snow and ice. And people are rethinking that here today. I mean, the US left behind thousands of gallons of diesel fuel, some radioactive waste, millions of gallons of raw sewage. They would actually do the reverse of their water well installation and essentially discharge the sewage to a sump that would melt the ice and go deeper and deeper into a larger diameter opening. And their plan was to install the waste pit about 1,000 feet from the nearest living quarters. And because they were running out of time in 1959 and 1960 to get this facility in before the winter, they took a shortcut and only installed the waste sump about 150 feet away from the nearest housing module. And that was a mistake. The odor was terrifically strong, and it was a bad deal. But suffice it to say, there's millions of gallons of raw sewage still there at that facility under the ice cap. So I don't know if the U.S. plans to go back there and clean that up. It depends on, I guess, our relationship with Denmark. Greenland is an independent territory of Denmark. And I mean, this whole area is just extremely fascinating to me, but clearly Greenland played an important part of U.S. efforts during the Cold War, and as well as ongoing efforts today with that base now being a Space Force base, the base in Thule, that is. By the way, they renamed Thule Air Force Base to Pitifik. So I hope you all enjoyed this video. I think it's extremely interesting. Again, the reference material links are in the description to this video. Also, I want to remind everyone I just opened up Buy Me a Coffee, which is an excellent way to support the channel. I actually keep a higher percentage of the proceeds compared to YouTube's take, but all sources of support are welcome, as well as those of you who are members to the channel and provide super thanks. That's another great way to support the channel. And of course, those of you who watch these videos and comment, I really appreciate your efforts. So let me know what you think about this whole base situation in Greenland, and please stay tuned for future videos. Thanks very much, everyone.